So, hi there. Hello, everyone. How are you? Okay, I hope all of you had a good day. Anyway, today I'm back with another topic, and that is convergence and divergence. And this is a very interesting topic and a very easy topic. But first, let's try to understand the concept as always. So, have you ever heard the word convergence and divergence? Maybe some of you have watched the movie Divergence. No. I'm not talking about that. I'm talking about the mathematical word divergence or the mathematical word convergence. Okay, I want you to take a look at this picture. And once you have a very good look at the picture, answer me whether it is convergent or divergent. Okay, let's move on to the picture. I have some squares here, and I made the squares in an approximate manner that the first square and the second square will be like 1/4. When you compare the first one with respect to the second one, it's 1/4. Or the second one is like 4 times in area, and the third one is again 4 times in area. So naturally, the next one will not fit my screen. So, my question is, if you keep on adding such squares, that is, you keep on creating squares with area 4 times the preceding one, finally, what will happen? You just imagine you made like hundreds and thousands and millions of squares like this. Just imagine what will be the area of the last square you made. Yeah, it will be something like this. It will cover the entire world if you try this experiment. And this concept is mathematically called the divergence. That is, you keep on adding some numbers, and the numbers become so big that you get infinity. I'll repeat, you keep on adding some numbers, and finally, when you add all those numbers, the answer will be infinity. And that is what we call divergence. Okay, friends, now I want you to take a look at another picture. So let's have a look at this one. Okay, now take a look at this picture. The red squares. Here, what I did is I have a square, the first one. Take a look at the first one. And the second one is approximately 1/4 the area of the first one, and then 1/4 the area of the second one. Look, the squares are becoming smaller and smaller and smaller and smaller, and 1 2 3 4 5 6 7 8 9, and it disappeared from our view. So even though we cannot see, there are like small squares. Now imagine what will happen if you add all these squares or the areas of all these squares. Or just tell me what will happen if you make 100 squares like this. What will be the size of that 100 square? Even though we cannot see, just try to visualize it. It will be so small that it will be like crushing a dust into million particles. Okay, now think about adding all the area or all, just pasting all these squares together. Do you think you are going to get a big square or an infinite square? No. You'll get a finite one, a very small, maybe one more square along with the first square. And this principle is called convergence. And this is something which we never imagine, because normally the human brain works like, if you keep on adding certain things, we get infinite. That's what we think. But my friends, we have this case. That is, the squares or the numbers becoming smaller and smaller and smaller, so that even if you add all the numbers till infinity, you're going to get a finite answer. And that principle is called convergence. Okay, now let's move on to some numbers. Okay, take a look at this series. Do you know what's a series? Okay, I want you to take a look at this pattern or the sequence 1, 2, 3, and so on. Okay, this is called a sequence, and a series means sum of all the terms in this sequence. So a series is nothing but an infinite sum. So I want you to remember the blue squares. So look at this 1, and then it becomes bigger, and then it becomes bigger, and then becomes bigger, etc., etc., etc. So definitely we will end up with the value infinity. So if you add all these numbers, eventually you'll reach infinity. That means the number becomes very big and it goes out of control, and we call it infinity. At the same time, if you have a series like this, I'm sure most of you might have learned this in your high school classes. It is called a geometric series, and the sequence is called the geometric progression, and the common ratio is 1 by 2. I'll repeat, the common ratio of this sequence 1 comma 1 by 2 comma 1 by 2 square is 1 by 2. And in your high school classes you learned that when the common ratio is less than 1, then sum to infinity will exist. And I'm sure you learned a formula a by 1 minus r. And if you apply that formula, you'll see that the sum of all the terms till infinity is just 2. Okay, that is something really interesting, because normally we think when we keep on adding numbers again and again and again and again and again, in this case we are adding up to infinity, we are ready to add up to infinity, still we get the number or the sum to be 2. Okay, so this principle is called convergence. So I want you to take a very good look at the first one and the second one. And when you take a look at the first one, I want you to remember the blue squares. When you had the blue squares, the area kept on becoming bigger and bigger and bigger, so that finally you got infinite area. So likewise, when you add these numbers, the sum becomes so big that we can call it infinity, or it tends towards infinity. But in the second case, I want you to remember the red squares which kept on becoming smaller and smaller and smaller and smaller, that it disappeared from our view. Or in other words, the sum of all these numbers will be finite, and that principle is called convergence. Anyway, throughout this video, I'm planning to use this notation. And whenever I write this notation, you should understand I'm talking about convergence. And whenever I write this D inside a circle, you must understand I'm talking about divergence. But in your examination, don't use this notation. It's better that you use the word divergence and convergence. Okay, let's move ahead. I'll introduce you to a completely different series. Okay, now take a look at the third one. What do you think the value is? Okay, anyway, let's try. What is 1 minus 1? Yes, and again 1 minus 1, and again 1 minus 1, and we keep on doing this till infinity. Then the answer must be equal to 0. But if I group this one, like I'll keep the one here, and then I'll group the second one and the third one, and then these two, and I'll keep on adding like this, because we don't know whether infinity is even or odd. We don't know how many terms are there, we don't know how many numbers are there, we just know it's up to infinity. And if I do such a grouping, I'm going to get the value 1. and such a series is called oscillatory series. So once more, look at the first one, it's called divergent series. Look at the second one, it's called a convergent series. And now take a good look at the last one, it's called oscillatory because it keeps on oscillating between the two values. Okay, and it's clear that the oscillatory series was generated because of this negative quantity. So what I'm trying to convince you is, if a series has all the terms positive, then it will either diverge or converge. Okay, let's move ahead. Okay, so as usual, I want you to take a sheet of paper and pen. So pause the video, take a small break, and take a piece of paper and pen, and I want you to note this. Okay, so it's a very important definition. Divergence. So what do you mean by divergence of a series? It means when you add or when you find the sum of the series, or when you find the infinite sum of the series, the answer will be infinity. And what do you mean by convergence of the series? Okay, convergence means when you add all the terms in a series, you get a finite answer. So it's very interesting. You keep on adding again and again and again and again, infinite number of times, still you're getting a finite answer. And that is called convergence. Anyway, you can note one more definition: oscillation. And oscillation means you're going to end up with more than one answer. And remember one more thing, such a series will be generated only if there is negative sign. If all the terms are positive, you'll have only two possibilities. One is called convergence and the other is called divergence. Okay, so I hope you are noting all these points, the definition of divergence and then convergence and finally oscillation. Okay, so let's move ahead. Okay, now I want you to note the notation. As I told you before, a series means you keep on adding the sequence. And I hope you're familiar with UN. Some books might use the notation TN or AN. So UN, TN, AN stands for the general term or the nth term. Okay, now the next one, sigma UN. I'll repeat, sigma UN. Sigma stands for summation, or you can write like this: sigma n equal to 1 to infinity. Look at this, this is called the counter of the summation. That means you're supposed to put n equal to 1 here, so that you'll get u1, and then sigma says plus. So u1 plus u2 plus u3 plus etc. So remember, a series can be written as sigma un, simply sigma un, or you can use the counter n equal to 1 to infinity sigma un. Okay, now the sum of the first n terms, it's denoted by Sn. And next one is very important. I already told you. Imagine all the terms in a series are positive. Imagine all the terms in a series are positive, and that is called positive termed series. And you'll have only two options: either the series will converge or the series will diverge. And did you note all these points? Okay, now let's move ahead and let's learn the techniques to test for convergence and divergence. Okay, so we have a very important series called the P series. What do you call the series? Yeah, it's called the P series. Right now, you can learn the nature of the series without proof, but in the next video or in one of the videos, I'll be uploading the proof behind its convergence and divergence. So, I wanted to note one thing, something very, very important. This series over here is called the P series. It's very easy to understand. You put n equal to 1. So you'll get 1 by 1 power p. And then you put n is equal to 2. And then you put n equal to 3. And sigma always says plus, 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 dot, dot, dot. And this is more important. Please make sure you note it. Our P series will converge if this P is bigger than 1. You put any number bigger than 1, the series will be convergent. And if you consider any number less than or equal to 1, then the series will be divergent. Okay, now let's go for the first test. And before we go to the first test, I want you to have a very good look at the P series. So what is a P series? Sigma 1 by n to the power p. I have a few examples. Suppose you put p is equal to 3. That is, you have 1 by n cube. As you see here, the value of p is greater than 1. The value of p is greater than 1. That means our series will converge. Now take a look at the second one. 1 by root n. That is 1 by n to the power 1 by 2. And as you see, the power 1 by 2 is less than 1. So naturally the series will, you're right, diverge. Now take a look at the third example. 1 by cube root of n. And cube root is n to the power 1 by 3. And 1 by 3 is less than 1. That means the series will diverge. Okay. And the last example, that is 1 by n. And n means n to the power 1. And n to the power 1 means, it's here. Because it says p less than or equal to 1. So the series will diverge. Okay. Now the most important and the first test, that is limit comparison test. Okay. So the test starts like this. Consider two series sigma un and sigma vn, and assume that both of them are positive termed. Do you remember the meaning positive termed? Yeah. It means all the terms in the series are positive. And one more thing, the series will either converge or diverge. There is no third possibility, it cannot oscillate. Okay, now what you do is, you have to find this limit. In your high school, you learned how to evaluate symbol limits, and that's more than enough. So we have two positive term series, sigma un and sigma vn. And then what we do is, we find the general terms un and vn. We take the ratio and find the limit as n tends to infinity. And suppose the value of the limit is L. Okay, now comes the most important part. Let's say the value L is not equal to 0. Take a look at this. We found the value of the limit, and the value of the limit is L, and Now assume the value is not equal to 0 and is a finite number. In other words, it's not equal to 0 and it's not equal to infinity. It's weird to write like this. That's why in your books they write it's not equal to 0 and L is finite. Okay, so what's the conclusion? If L is not equal to 0 and is finite, then both the series will behave alike. So what does it mean by saying behave alike? Okay, if the second one converges, the first one must converge. So what does it imply? If sigma Vn converges, then sigma Un must converge. At the same time, if the second one diverges, then the first one must diverge. Okay. Okay guys, I wanted to take a look at this same video once more and make all the concepts clear so that we can move ahead and start with the numericals. In the next video, we will be doing numericals related to limit comparison test. So till then, bye.